In this video, we're going to be talking about what is direct variation and how do we use it to solve problems. So, let's begin with talking about what direct variation is. So in this slide right here, I have two tables that have direct variation. And basically, what makes it have a direct variation is that its y-intercept is 0. So it goes through the origin. Because of this, if we notice here, our slope is 30 over 1. Well, this is my constant of variation. In order to get from t to d, all I have to do is multiply by 30. There's no addition here with the y-intercept. So there is a direct relationship between my t and d here. It is times 30. So yes, this is my slope. And what we call our slope in this case here is our constant of variation, or our k value, which is 30. This is our constant of variation. What I am doing to my input to get my output. So again, here we're going through the origin. So there's no y-intercept where I'm adding something. I'm just basically, if I notice here, I'm going up 6 over 2. So my slope here is 3. So basically, all I have to do to get from my x to my y is multiply by 3. Multiply this by 3, that gets you 9. Multiply this by 3. And so that's all I have to do. I don't need to add a y-intercept as well. So again, this table right here has a direct variation where y varies directly with x, and our constant of variation here is 3. Okay, so let's go ahead and put this in proper terms. So direct variation is a linear function where y varies directly with x. So we're going to put directly with x. So you're basically going to have an equation that does not have a y-intercept. It's going to look like this. Y is equal to k times x. Yes, k is your slope, so we could have used m. But we're using k because it's even more special. It's it's our little ratio there that we were getting here in our table. So that's why we're using k. But it's the same thing as m, really. It's our slope. Where k is the constant of variation. And so this k becomes really important. And we can basically get an equation to get k. Well, how would I get k by itself here? Let's look. I am multiplying this by x. So if I'm trying to get k by itself in an equation in terms of k, I can just divide both sides by x, and I would have y divided by x gets you your constant of variation. Let's go back to our tables. Well, how would I have gotten my constant of variation? By going backwards. 30 divided by 1 is 30. 6 divided by 2 is 3. 9 divided by 3 is 3. Again, we get our ratio value, and that's how you can get your k value, or your constant of variation. So let's go ahead here and look at our graph. So obviously, this is a direct variation because it is going through the origin. And so we can write an equation where all we really need is the slope. So if I look here, my slope it's going up 1 over 2. So our constant of variation here is 1/2. I can write that y equals 1/2 times x. Another way that I can write this is I can write that every single time I take my y values and divide it by x, I get a proportion of 1/2. That is the ratio that is going on here. So just like we did here with our k. When we divide y divided by x, you get the k value. Okay, so y here varies directly and I kind of ran out of room, so I'm just going to write directly up here with x, and the constant of variation in this case is 1/2. And so we have to remember that in order for it to be a direct variation, it cannot have a y-intercept. So it must go through the origin. Or let's go ahead and write here, origin. All right, now this table right here, a quick way where you can tell if it's direct variation, even if you don't see the 0, 0, is there a number that I can multiply to get from 6 to 12? And does that same number work from 7 to 14 and 8 to 16? Well, let's see. If I go backwards, 12 divided by 6 is 2. So yes, I can multiply this by 2. Same thing here. Same thing here. So this is a direct variation. There's a direct variation from y to x. Y varies directly with x. And our equation here would be y is equal to 2x. Another way that we can write this is we can solve for the constant of variation by writing y over x equals 2. And so here again, y varies directly with x, and the constant of variation here is 2. So what we need to be thinking here is when there is a direct variation, basically there is a proportion. Here my proportion is 1/2, and here my proportion is 2. So let's use that concept to go ahead and solve problems. If y varies directly with x, and x equals 9 when y equals 6, find x when y equals 15. Well, let's set up a proportion of y to x. Well, again, they're proportional. My y and my x are proportional to each other because they vary directly. So I can make a proportion of 6 over 9. So this y over this x is equal to, I'm trying to solve for the x, so I'm going to put the x down here, so just keep your x's aligned, is equal to, so 15 over x. So basically, right, we should get the same number. When I divide 16 by 9, you should get the same number as when you divide 15 by x. Let's look at the examples we've done here. 12 divided by 6 got us 2. 14 divided by 7 got us 2. Again, there's a direct variation. So because there's a direct variation, I can set up this proportion. And then in order to solve this right here, we need to do cross multiplication. So 6 times x is going to be 6x. And then we need to do 9 times 15. And we're going to get 135. And then we need to go ahead and divide that by 6. And so when I divide that by 6, we get that x is equal to 22.5. Now let's do this next example here. So it's saying that Hooke's law for an elastic spring states that the distance of a spring stretches varies directly with the force applied. That means force is proportional to distance. And so if the force is 160 and that stretches a spring 5 centimeters, how much will a force, they gave us another force here, so I'm going to go ahead and align it here, stretch that same spring? All right, so I need to go ahead and do cross multiplication here to solve for x. So I'm going to have 160x is equal to 5 times 368. Here I get 1,840, and then in order to solve for x, we need to divide both sides by 160, and then here we're going to get another decimal, that's okay, 11.5. So that would be 11.5 centimeters if we were using our units here. Okay, so that is the end of this video, and I hope that you found this helpful on what is something that is directly proportional and how we can use that to solve actual problems.